Okay, I've got the Wissota 911 here. You kick it on. You use this to kiss the wheel. Set up to 5/8 over here. Right here. Bring this into it, just kisses the wheel. So that sets the radius of curvature. That's a stainless steel blade on a CCM. These are actually replaceable blades. And that's actually gotten the edge with 3 passes fairly well. Sharp. It's on a pair of rental skates. Could probably do one more pass. Right here it's a little bit raspy right here. You don't have to go too crazy on the edges because you're going to go ahead and screw up the profile. Anytime skating, you've got good time on any sharpener. You don't want to sit there and wail too much on here. So I tend to go mostly in this region and just a little bit on these other regions on here. You can leave this in the fixture to go ahead and check it with the gauge. You don't have to take it out. And this is a little checker I've got here. Goes on here. To see if it's square. And this is a Starrett. Actually I use for figure skates. It's a double end square, a 14D, a little bit higher end, and you can put that joker on there and see it's squared right up. You check on both the front here and at the back, because you can get in a weird situation where if somebody's got a holder goofed up, it can be to where it's this way at one end, straight in the middle, and then like that. But this is pretty much dialed in. Once you've got your holder dialed in, you don't have to fool with the settings down here on the dials, unless you got a thicker pair of skates, and then you move them all up equally. So this is the 3D skate holder from Wissota. This machine actually runs counterclockwise. A lot of the other ones run clockwise. I've never really found that to be a problem because I used to use this old Wissota S8 back at the Caneo Valley rink in Thousand Oaks, Newberry Park, and it was an older machine than this in the early 80s, and it has the same Z height, and you got a holder that I'd bought years ago when I was doing some helping out there. This is my own holder. And that fits on there. This is actually an easy sharp machine, but this one that I went through, and there's an adapter on here to add this higher. So that's got the same height as this. And these machines last a long time. There's really almost nothing to go wrong with them. If you get a used machine, you want to be aware that you want to make sure there's no parts missing on the holder. I mean, buying a holder like this can be $250 to $400, depending what the brand or whatever, but the Z height varies. Wissota is pretty much consistent for a long time. I think on the Easy Sharp machine they've had 2 different Z heights over the years. And then Blackstone and Blade Master can have sometimes a different Z height. And you just don't want to go ahead and assume that buying a machine without a holder is kind of a liability. If you can do a local pickup one, it's better because you can sit there and make sure there's nothing missing. You know, there's not a part missing on it. If it's something that's from an estate sale or something, it's real easy for something like this just to get thrown in a box and get lost. And then you've got a machine with a part missing on it. But the old S8 that was on this, it wasn't as stiff as this. This has been out, I want to say, for about 20-25 years probably. And this has got a much thicker, the diameter of the motor, this is much more stiffer. And of course this is a spark guard on here that is used. This is just, you adjust this so you don't go ahead and you catch some of the crap that's on here. And after you've done probably a pair of skates or so, you can go ahead and dress the wheel on this. That's to keep the radius of curvature. Now this one you can adjust the radius of curvature here from, it's got 7/8, 3/4, half, 3/8, 1/4. And I guess I goofed you. I had this on a 1-inch radius on here. So we're going to go through here and show my mistake here. I'll show how the adjustment on this works. I'm going to pull this back. So you got 7/8, 3/4, a 5/8, a half, a 3/8, and a 1/4. I'm going to go ahead and pull this back and set this to what I'm doing over here is I'm undoing these screws right here. I'm doing this and pulling this back. And I'm going to set that to, there you go, 5/8. It just goes to show you when you do something like this, you have to be kind of aware of what's going on. So that's the reference, the top of the screw, there's a 5/8. That means from this pivot point here to the diamond is 5/8 of an inch. Radius of hollow right there. So I'm going to go ahead and bring this in like this. Snug these down just a little bit so it's stiff. Going to track true. There you go. Now we'll put the skate back in there. And let's put it in this way. We'll zoom in here. Got a little bit of a cold coming on. And I had that set for about 1 inch because I was doing something the last time I used this, doing a cleanup on a different type of skate. And if you zoom in here at the wheel, you can see that it's only contacting the center of the wheel. And don't be worried if it's not exactly in the center, because that doesn't really matter. The pivot point of this, when this cuts this, it's going to go ahead and make the bulge to be out like this, and so you adjust the Z height to match. Probably done enough passes to get the new radius of curvature on there. And I purposely got a blower off here so you don't sit here and hear the noise of the blower. I purposely didn't go very far up on the toe here. That's square. Then you go through and take a stone, hold it like this, knock the burr off. Okay, once I'm done with the skate here, take and purposely knock the burr off. So this is held. You don't want it tilted like this. You want it to be just flat on there. And that just knocks the burr off. And I'm probably not filming this very good here. There you go. Got a nice edge. One of these tabletop machines like this got a long lifetime on it. The good thing is the cost per cut is less than an automatic machine. The negative in any tabletop machine is that you've got knobs it can be fooled with. So if you've got a communal situation where somebody's going to mess with this, you can either get another holder, lock it up, just make sure that somebody's not sitting there turning the knobs, because you know I have to go through and adjust this back to get it in. But once it's dialed in, you almost never have to fool with this, because pretty much all hockey skates are the same thickness. And what you can do is take a micrometer and measure the thickness. And if you've got some brand that are slightly different, you can go through and adjust those and do those all at the same time. But if it's your own skates and stuff, you can go long time without having to fool with the holder. If you get a new pad that's on the bottom here, of course that wears with time, so you have to sometimes tweak it in, but you can go ahead and do gobs of skates without messing with this thing. And that's on any tabletop machine like this. So that's why one time I had my own holder when I used it as a rink, so I could just go through and not have to get into a fight with somebody about trying to goop their machine up. So we got a good edge on here. So on a tabletop machine like this, if you get a pair of skates with a thicker blade, when I say thicker, this is closer to 3 millimeters thick instead of 4 instead of 3. It's way thicker. You've got to adjust the Z height up and down. It doesn't matter what brand you use. So that's why I've marked this thick blade here, just because if you stick it in here, you're going to go ahead and have it one edge way higher than another. So that's why I've marked this as being a strange thickness. Very unusual for a hockey blade to be 4 millimeters thick, and that's made in China. So with this, what you do is you're going to adjust all these equally up or down. So these little magnetic things will peel off. You can peel this off, put them where you want to. So you can turn them all equally, and you can take a pass on it, or you can go through here and measure with the micrometer how much you have to move this. You actually move this down half the amount of the difference. So if you had a blade that was 4 millimeters thick instead of 3, you're going to go ahead and move this down. If you put the thicker blade, of course it's going to be high. Imagine if you had a blade this high. It's way too high. But you don't move it down, you move it down half the amount. So 4 minus 3 is 1 millimeter. You're going to move it down half a millimeter, about 20 thou down. So what I tend to do on this is you go through and have skates that are weird, put those aside. Ones that have a different radius of hollow, if it's most productive to go through, if you're doing a bunch of 5/8, set the machine at 5/8, do a whole bunch of them at 5/8. Sometimes it depends on what the preference is, the weight of the skater, whatever. 5/8 is a real good radius of hollow, I found. And if you go through and use that, you don't have to sit there and redress the thing all the time. You get more life out of the wheel. Generally you get about 200 sharpenings out of a wheel like that. So you'll get more life out of your wheel if you don't sit there and change the radius of hollow every time, because you have to cut the wheel down to do that. So if you had a bunch you're going to do at 5/8, do all those 5/8 inch ones. If somebody wants a 7/8 or something like that, do those 2 or 3 pairs of 7/8. Then it's more productive your own time. Even on an automatic machine, you're not sitting there changing the wheel, automatic cutting wheel back and forth. Or on this, if you do this one in the middle of the swing and you go through and have to adjust it up and down, that's just a waste of time. So your workflow is you can do more skates by going through and doing them in waves by what the size is. It's kind of sometimes a little bit goofy. Somebody wants to go from 5/8 to a half. Sometimes they just do them at a different time. And sometimes a small amount doesn't make that much difference compared to the sharpening. Okay, normally on a tabletop machine they make a hood optional stainless steel thing to catch the debris. You can't just use a shop vac and get it close to this and pick up a lot of it. You can rig up something. And I didn't have this on when I was filming just because it makes a lot of noise. You can go ahead and have the pipe farther away to reduce the noise. And sometimes I just put the nozzle of this, if I don't have the shroud here, get this close and picks up the bulk of the dust. So when you're cutting here, it's going to come through and suck all this stuff right into here. I'll try to do this one-handed. See, going into the shop vac nozzle. You want to make sure you got a long enough hose so the sparks are not down there into the filter. That's kind of the poor man's way of doing it. But that gets a lot of the debris. Just having something right there. I'm just pushing that along with one hand. That's a 911. A carbon steel non-stainless blade looks like. The spark pattern is more different like this.